Hello, AGers. We are going to start chapter 9 today with 911, and we're going to look at inequalities. Today's lesson should be pretty comfortable. It's a bit of a flashback from M3, so let's see what we remember. We are going to start with a set of integers, and we're only going to talk about integers from -5 to +5. So this would be -3, -4, -5. This would be 4 and 5, okay? So if we wanted to represent which of these integers from -5 to +5 would make a true statement if x is greater than or equal to -2, we would begin with -2 because -2 would be equal. This is an or statement, greater than or equal to, and then anything bigger than -2. So -1, 0, 1, and we'd go all the way up and we would include 5. So we're only talking about this set. If we were talking about all integers, of course, we'd continue forever. Now, we've got a compound inequality. So this is where we come up with a range. This is an AND statement. I need an integer that is greater than -1 or equal to, and I need an integer that is less than or equal to +4. So I would start with -1, bigger, 0, 1, and I'd keep going until I got to +4, right? +4 I could do is equal to 4. 3 is less than 4 but greater than -1, and I'd include all the integers in between. If I have an equal statement, we're just one and done. Only one number equals 3, and that would be 3. If I wanted to know which of these integers up above are less than -3, then I would only have -4 and -5. If I wanted to know which integers have an absolute value of 4, remember absolute value, I have -4 and +4. They're both 4 units from 0. Now, I have an OR statement. So they don't have to overlap. They're going to go their separate ways. I need all the integers that are less than or equal to 1, and then all the integers that are greater than or equal to 5. So if I want anything that is less than -1, right? So up here, if it's less than -1, I would include these. Anything to the left. If I want any integers that are greater than or equal to 5, right? Only 5 is greater than or equal to 5 from the integers I have. So I'm going to go from 1 all the way down to -5. So -5, -4, 3, 2, 1, 0, 1, and then I'm going to include 5. This is an AND statement. This is going to be a range again. I want integers that are greater than -5 but are less than or equal to 0. So greater than -5 would start with -4, right? And I keep going. But I have a max of 0. So I would continue until I got to 0. So really, I guess I could have just written the -1. There we go. And then the absolute value of the number has to be greater than or equal to 2. So obviously I could plug in 5, right, would be greater than 2. 4 would be greater than 2. 3 would be greater than 2. 2 is or equal to 2. So I'd include 2, 3, 4, 5, and then of course -2, -3, -4, -5, because the absolute value it would be a positive. All right, So we're going to look at a couple of situations here. If I'm looking at an inequality to something like x is greater than or equal to -2 versus x is equal to something, if I am just looking at any integer there is possibly could be, if I'm at x is greater than or equal to -2, I would have an infinite solution because there's an infinite numbers that are greater than -2. They go on forever. If I want a number that's equal to 3, there's only one solution. There's only one number that's equal to 3, and that's 3. So if I have x is less than 1, I should have an infinite solution. It's going to go on in one direction forever. If I'm looking at b and g, right? So remember, b was -1 is less than or equal to 4, which is -1 is less than or equal to x, which is less than or equal to 4. Remember up here we talked about this is an and statement, so we're going to have a range where if we look at, and when we look at g, right, we still have that and statement. We have x is greater than -5 and x is less than or equal to 0. We're going to have a range again. So when we have an and, we're often going to have a range. That compound inequality gives you sort of the two bookends, the high and the low. Now, when we look at F, we have an or statement. Okay? So whenever I have an or statement, I can go, typically I'm going to go in opposite directions, and we're going to go forever. You're going to have an infinite number of solutions. Typically opposite directions. All right. So this is one direction. This is going to be one variable with one endpoint, right? My value that I'm talking about is 1. 1 is included because it's solid and it's greater. The numbers are greater. Oh, if it's greater, I got to write it greater. So greater than or equal to 1. Just do a mental check. 4 is shaded. 4 is greater than or equal to 1. I know I'm all set. This is a one direction as well, and I'm comparing it to -1. I need to be less than -1. Do I want to include -1? No, I don't. I don't want to include it because it has an open dot, so it is excluded. So it is a less than. -5 is less than -1. So open, excluded, closed, included. All right, this is going to be my or statement because I'm going in opposite directions. I need my x to be greater than or equal to 2, or it's going to be less than -3. Included, solid, equal or equal to. Excluded, open, it's going to be a less than or a greater than. In this case, it was less than. All right, now I have a range. This is going to be an and statement. My two numbers I'm talking about are -4 and +2. You start with the low to the high. You can always use less than symbols. Excluded, leave it as less than. Solid, included, it's going to be a less than or equal to. So x is greater than -4, less than or equal to 2. Now, this one is the one to get you thinking. It's got everything except it's got an open dot on -2. So -2 is the only thing that is not a solution. So I'm just going to write this as a not equal to -2. It can equal anything else. It's up to you. just not -2. All right, I've got another opposite direction. So this is going to go for or. I have, this looks, it's partway between 3 and 4. I would say 3.5. Notice I only have integers on my number line. So this is greater than. All right, I wrote my 3.5 there. So x is greater than. It's included, so x is greater than or equal to 3.5. I could have written it this way. I know you're probably a little more comfortable of reading it left to right instead of right to left. So the next one we're talking about is -4. X is less. It's included, so it's going to be less than or equal to. Remember, you always read in terms of the variable. We typically like to start with the variable, but it won't always come first. All right, so far so good? All right, we're going to take a look at the flip side. So, on the flip side here, we're going to make this, figure out what values are going to be true for this. So, in order to solve for this, I'm going to solve this inequality. I'm going to add 5 to both sides, and I'm going to get 2x is greater than or equal to 8. So x is greater than or equal to 4. So 4 would be a possible solution. 5, 6, 7, and so on. So if it keeps going forever, then there's an infinite number of solutions. The smallest value I could have for x is 4. And now, this 4 is the smallest value. We call that the boundary point. The boundary point is where you start your inequality. You start your ray. So when I go to graph this, I want to put 4 in the center because that's where the action is. And then I'm going to put a couple of integers on either side. Don't be cheap with this, okay? I don't want to see like 2 things or 3 numbers written down. You got, take your time, do quality work. You're a quality person. So, if it was an equal statement, right? Then up here, instead of having a greater than symbol, I'd have an equal symbol, so x would equal 4. There'd only be one answer, and that one answer would be a solid dot on 4. If it's greater than or equal to 4, that means anything to the right is going to work. So I'm going to shade in. Notice I'm shading above and below, and I'm shading right over the arrowhead. Okay? So the inequality that represents that, we already did it, is x is greater than or equal to 4. Okay? So far, so good. Now, if we're looking at the difference, right? If we're looking at how can you quickly solve for the point once you've determined the strategy, if you find the boundary point, right? If I'm looking at a less than, if I have one variable, right? It's going to be on a number line. There's only one boundary point because this is a one-directional. There's no and or statement. So once again, I would solve for this. I would add a -3 to both sides. So -2x is less than -2. You know what? Actually, what they're going to ask you to do, if we were just to identify the boundary point, we could end up, if we just want to know where are we going to put that first dot like we did here, if I solve it with an equal sign, I would put my first dot on number 1, right? So if I did my number line here, and this is 1, 2, 3, right? I would end up putting what type of dot? I'd put an open dot on 1. and then I would figure out which way to shade. So we know the boundary point happens to be at 1, and there will only be one boundary point because it was a simple inequality. Now, when I look at this inequality, is the boundary point going to be opened or closed? If it's included, then we would do a closed dot, right? If it's excluded, we do an open dot. In this case, it has to be less than, so it will be excluded with an open dot. So now, if I'm looking at my inequality and I just want to pick a number to say, if I want to just use some mathematical reasoning, what would be a good point to test? 0 is often a great number because it's easy to add, subtract, multiply, or divide. So if I'm looking at 0 and I plug 0 in, does it give me a true or a false statement? If I'm looking, right, at 3 minus 2 times 0, will that be less than 1? Is 3 minus 0 is 3 is not less than 1. So 0 is not going to be part of my solution. So if I'm looking and 0 is to the left, that is not part of the solution. I want to then shade to the right. So I would shade right over here. Okay, yep, that is my cell phone. I'm going to just send a little message. Sorry about that. All right, here we go. If you noticed up here, when I solve this inequality mathematically, 3 minus 2x is less than 1. When I have negative 2x is less than negative 2, when I divide by a negative, if I want the numbers that are greater than 1, right, I'm doing the opposite. I actually take the opposite inequality, and that's where I get x is greater than 1. So when I divided by the negative 2, right, I'm actually, when I divide by a negative or multiply, I take the opposite inequality. So let's look at the last one here. If I have 3x plus 1 is less than 7, that's 3x is less than 6, so x is less than 2. Give me a number that's less than 2. Yep, that's right. Pick 0 because it's going to be easy to add and subtract. 0 plus 1, is that less than 7? It sure is. So you know you picked the right, you know you'll be shading to the left. What kind of dot should you put on your 2? That's your boundary point. It's going to be open because it's excluded. And I'm going to shade to the left. Now, that's what we've got for today. If you didn't remember about when you divide by a negative or multiply by a negative, you flip the inequality. We're going to take another look at this in another day. So we knew we shaded to the right because we did our mental math. You always want to just double check with your mental math because you've got great reasoning. All right, you're good to go, and I will see you again soon. Bye-bye.